Okay, welcome back. We are looking at example 4, determining the domain and range of an area function. Okay, this is going to be a real life application question. We'll see how domain and range plays a part in that. So in this question, we can see um, it says Amy volunteers to help enclose a rectangular area for a dog run behind the Humane Society. The run is bordered on one side of the building. The society has 100 meters of fencing available. Let's just draw a quick picture of this. So uh, there's the Humane Society. Okay, this is the top view of this building. Okay, and they want to build a dog run, and it's going to be bordered on one side of the building. So let's just assume the dog run is built over here. Okay, there's a total of 100 meters of fencing available to build this dog run. So that means they could do something like maybe they could do 10 meters here, 10 meters here, and they could have the other 80 there. Okay, that's one combination. They could also do something like maybe 30 here, 30 here, that adds up to 60. So there'd be only 40 left. And there could be that combination. So either way, those dimensions are going to represent an area on the inside of here. Okay, so in order to create an area function, what we're going to do is we're going to call this width here, we're going to call it a variable. So instead of giving it a number, we're going to make it a variable. Okay, and we're going to call it x. So there's an x on that side, and there's going to be an equal x on the other side. So I'm just going to write that down. Okay, and this will be helping us to start off part A, trying to get that area function in terms of the width. So we'll say let x represent the width. Okay, and it's going to be in meters. Those are our units. Okay, so x is the width, it's this side and this side. So because we've already used up two x's and we only have 100 available, I know that for this length here, all we have left is 100 minus the two x's that are on both sides there. Okay, so these are x is my width, and 100 minus 2x is the length. Okay, the area will give that symbol A. So I can write that in here. Let A represent the area function. Okay, and that's going to be in meters squared. I'll put the exponent there for that. Okay, so I'm now going to write out a formula for the area. We know area is always length times width. So my length is 100 minus 2x, and the width is x. Okay, and now we're just going to distribute this in. Okay. So we'll do this one first, x times negative 2x. That gives us negative 2x squared. And then we'll do x times 100. That gives us 100x. Okay, and this is my area function. Okay, notice the area is in terms of the width. The width is x, and that is what we were asked to do for part A. Find the area function in terms of the width. Okay, so when you're doing questions like this, you will always need to start off with one of these statements. You're going to have to introduce a variable x, and you have to let it represent something. Okay, usually it'll be what they're asking for in terms of the width. Okay, all right, and part B. Part B says determine the domain and range for the area function. So notice this is now a nice equation, this area function. How about we graph it? Okay, we will use Desmos to do this. Okay, and I pulled it up already right here, the equation. So negative 2x squared plus 100x. Okay, we can see it's a parabola. It opens downwards. Okay, and it has an intercept at 0, 0, another one at 50, 0, and another one at 25, 1, 1250. So this is the area function, right, that I just graphed here. Now, does it make sense for the area to have like a negative value? No, it doesn't. For a real life application, if you're building a fenced-in area, an enclosed area, that area has to have some positive value. So we want everything to go from the two intercepts, 0, 0 to 50, 0. We don't want to include anything outside of that because that represents a negative area. So I'm already getting a feel for the domain and range for this. I know in order to fit the context of this question, we need to restrict the domain so that we only have positive values for the area. And also the area has a limit too, right? That area doesn't just go up to infinity, but has a max value of 1250. Okay, I'm going to copy these out onto our handout, and then we'll use it to determine the domain and range. So this is just a quick sketch of what's happening here. I'll do the curve in green. Okay, this point is 0, 0. This point here is 50, 0. And this point at the top is 25, 1250. Okay. Remember, this is area versus the width. Okay. So my domain is now like in terms of the width, and the range is now going to be in terms of area. Okay, let's transfer this down here. So my domain, so x is going to be an element of the reals. And in order to get a positive area, I want to restrict x from here to here. Okay, I don't want anything outside over here because that will be negative values for a. So x is going to be greater than 0 and less than 50. The range, which represents my values for area, we're going to say a is an element of R. And the area, the smallest value can be 0, and it goes all the way up until 1250. So we have everything from here to here. So we can say a is greater than 0. That's what this means right here. And also a is less than 1250. So we will add that in as well here. Okay. And there you have it. That's our domain and range in context of a real life area situation. So here is our homework, which is for the rest of this section. And then there's one more question that's going to show up in the team's assignment, the ALL question number 3. Hope you found this helpful, and I will see you next time.